The parachute opens at 2,000 feet above a roadless wilderness in Idaho. Suspended beneath it, a wooden box. Inside the box, something is chittering, clawing, utterly confused. The year is 1948, and 76 animals are about to change everything about how we understand rivers, forests, and the silent architecture of the living world, but we don't know that yet. Neither does anyone on the ground. Below, the Chamberlain Basin stretches out in every direction, a vast cathedral of pine and fir, cut through by cold, silver threads of water, moving with quiet urgency toward the sea. No roads reach this place. No machinery could navigate its ridgelines or its river crossings. The men who designed this operation knew that. That was the whole problem. They had animals that needed to be moved. The animals were getting into trouble near human settlements. And there was all this wilderness just sitting there, waiting. So they built a box. They tested it. They loaded it. And they dropped it from a plane. The beavers survived. All but one of them. What happened next took decades to fully understand, and when scientists finally pieced it together, they found themselves staring at something that redefined what a single species could do to an entire landscape. Not in metaphor. In measurable, documented, astonishing physical reality. Think about what it means to transform a place, not to visit it, not to use it, but to remake it entirely, simply by existing in it and doing what you do. The beaver does not intend to create wetlands. It does not plan floodplains or design sediment traps or coordinate salmon nurseries. It builds a dam because wood is there and water is there and instinct is older than intention. But the consequences of that dam ripple outward in every direction, ecological, hydrological, atmospheric sum for centuries. We will come back to Idaho. We will come back to those 76 boxes and what grew from them. But first we have to understand what we are actually talking about when we talk about a beaver. Because most people think they know, and almost no one does. The beaver, Castor canadensis in North America, Castor fiber in Eurasia, is not merely a large rodent with a flat tail and an improbable relationship with wood. It is what ecologists call a keystone species. A keystone, in the literal sense, is the central stone in an arch, the one piece whose removal causes everything else to collapse. Remove the beaver from a watershed and the wetlands begin to drain. The meadows dry, the insects disappear, the birds that eat the insects disappear after them, the fish lose their slow water, their shaded pools, their hiding places and spawning gravel. The trees along the banks, deprived of the high water table the beaver had maintained, begin to die of thirst in the very places where water once ran. Remove the beaver, and you do not lose a beaver. You lose the entire world it was holding together. Beavers once numbered somewhere between 100 and 200 million individuals across North America alone. They occupied nearly every watershed on the continent. They had been engineering the hydrology of this land for so long, for millions of years, that the rivers and wetlands and meadows we see today were shaped in large part by them. Not by geology alone, not by rainfall patterns or elevation, by teeth, by mud, by the accumulated labor of an animal that works mostly in darkness, mostly in silence, mostly unobserved. And then the fur trade arrived. By the mid-19th century, the beaver had been hunted to the edge of continental extinction. Millions of animals vanished in a matter of decades. The demand for beaver felt, for the waterproof hats that European fashions required, for the pelts that financed exploration and colonization, was insatiable. Trappers moved west faster than settlers because the rivers told them where to go and the beavers were waiting there like a form of currency with a heartbeat. When the populations collapsed, no one fully recognized what else was collapsing alongside them. The rivers began to change. Without beaver dams slowing the flow, without the ponds that spread water across the floodplain, rivers began to cut downward, incising into their beds, dropping below the level of the surrounding land, becoming isolated channels rather than living, breathing networks. Meadows that had been wet and spongy for millennia dried out and eroded. Willows and aspens that depended on that shallow water table retreated. The land compacted. It became brittle. These changes happened slowly enough that by the time Europeans were settled in the West, they had no memory of what the landscape had once been. They assumed the dry, eroded creek beds were natural. They assumed the sparse vegetation was what had always grown there. They did not know they were looking at an ecosystem in the long aftermath of a catastrophe. That is one of the quietest tragedies of ecological loss. The way it erases not just the living thing, but the memory of the world that living thing had made. The baseline shifts, the absence becomes the new normal. And we stop asking what was here before because we cannot imagine it. Ida Elaine McKean was a biologist working for the Idaho Department of Fish and Game in the late 1940s. The specific challenge she and her colleagues faced was straightforward in its description and impossible in its logistics. Beavers were congregating near farmland and causing flooding in populated valleys. They needed to be relocated. The relocation sites were identified: high mountain drainages, roadless and remote, where beavers had once lived and from which they had been extirpated. Getting the animals there was the problem. You cannot drive into the Chamberlain Basin. You cannot walk an animal for 100 miles of switchbacking mountain terrain. A horse might do it, but the animals are stressed by horses, and the journey is long. Elaine McKean and the records of this operation are charming in their specificity. Tried different boxes. She tried different parachute configurations. She ran tests. She collected data. And she discovered, with what must have been a particular kind of delight, that beavers are extraordinarily well suited to being transported by air. They are docile in darkness. They calm themselves when enclosed. Given a small space and no light, a beaver will largely stop struggling and wait, in the patient, unglamorous way that rodents wait for things to change. The first operational drop happened in August of 1948. 76 beavers were loaded into specially designed wooden boxes, each box equipped with a parachute rigged to open automatically on release. The plane flew low over the release points. The boxes tumbled out. The chutes opened. The boxes drifted down through the pine-scented Idaho air. One beaver, named Geronimo in the records because the men doing the loading had a sense of humor, was used as a test subject for multiple trial drops before the main operation. He survived everyone. He was eventually included in the main drop, released to live out his days in the wilderness he had, by then, become intimately familiar with, from a considerable altitude. The beavers landed. The boxes were designed to open on impact, and 75 animals walked out into a landscape that had been waiting for them for more than a century. What followed was not dramatic in the human sense. There were no crowds, no announcements, no monitoring equipment. The beavers simply did what beavers do. They found water, they found wood, they began to build. A beaver dam is not a crude thing. It is a sophisticated hydrological structure that responds dynamically to changes in flow. When water rises, beavers add material to the dam to compensate. When it falls, they may open gaps to reduce pressure. The dam creates a pond, and the pond creates a cascade of effects that most engineers would struggle to replicate deliberately. The still water allows sediment to drop out of suspension, clarifying the water downstream. The raised water table saturates the surrounding soil, encouraging the growth of willows, sedges, and other riparian vegetation. That vegetation stabilizes banks. Those banks become habitat. That habitat becomes a community. A single pair of beavers can, within a few years, transform several acres of marginal streamside scrub into a wetland of extraordinary biological richness. 75 of them, in a single watershed system, had time to do something much larger. The first serious scientific assessment of what had happened in the Chamberlain Basin came decades after the 1948 drop. Researchers using aerial photography, satellite imagery, and ground-truthing surveys found themselves looking at a landscape almost unrecognizable from the one that had existed before. Pond complexes that had not been there now covered dozens of acres. Willows and aspens had colonized stream margins that had previously been bare. The stream flow patterns themselves had changed. Water that had moved quickly and seasonally through the system was now retained longer, released more slowly, creating more stable flows, even through dry summers. But the more profound discoveries came from the biology. In watersheds with established beaver populations, researchers documented increases in macroinvertebrate diversity, the tiny aquatic insects that form the base of the food web for trout, birds, and everything that depends on them. Migratory songbirds used the willow thickets as nesting and feeding habitat. Amphibian populations, frogs, salamanders, species that require slow, shallow water for breeding, showed up in places where they had been entirely absent. And the fish. The fish told a particularly clear story. In streams with beaver ponds, wild trout populations were found to be significantly higher than in comparable streams without them. The ponds created slow, deep water where fish could shelter from high temperatures. The willow shade kept water cool. The abundant invertebrate life gave them food. The sediment trapped upstream by the dams kept the gravel downstream clean, and clean gravel is where salmon and trout lay their eggs. Remove the silt from the gravel and you restore the nursery. There is something almost unbearably elegant about this. The beaver does not know it is helping the fish. The fish does not know it depends on the beaver. The system does not require intention or awareness. It requires only presence, the right animal in the right place doing the right thing, and time to let the consequences unfold. How long does it take to know if something is working? How long does an ecosystem need once the missing piece is restored before it begins to resemble what it was? There is no single answer. Some effects appear within a single season. The ponds fill, the sediment drops, the water table rises. Others take decades. The return of a native tree to a riverbank requires the tree to grow tall enough to seed, the seeds to disperse, the seedlings to establish, the saplings to mature. That is a 20-year process at minimum. The recovery of a salmon run depleted by habitat loss might take a generation of fish, and then another, before the numbers rebuild. Restoration science has struggled with this. Humans are impatient creatures. We want to see results in the length of a grant cycle, a career, a news cycle. Ecosystems work on a different schedule, one measured in the lifespans of trees, in the slow accumulation of soil, in the generational memory of migrating animals returning to rivers their great-grandparents once used. The beavers dropped into Idaho in 1948 were doing their work long before anyone was watching closely enough to understand it. The landscape was changing beneath the notice of science, building itself back towards something older and more complex than what the mid-century West had come to accept as normal. This is what makes the story of the Chamberlain Basin drop so resonant, so persistently worth returning to. It is not simply a quirky historical footnote about animals in parachutes, though it is undeniably also that. It is evidence of something deeper, evidence that the world has a memory, that the template for abundance and complexity is still encoded somewhere in the soil chemistry and the hydrology and the seed banks of eroded stream banks, waiting as the beavers waited in their boxes in the dark for something to change. What does it mean to return something to a place? There is a word for it now, rewilding, and it carries with it both genuine scientific meaning and a kind of longing. The longing is for what was. The science is about what could be. These are not always the same thing, and it is worth holding both without collapsing one into the other. We cannot restore the continent to a pre-colonial state. We cannot undo the incisions we have cut into our rivers, the dams we have built, the aquifers we have drained, but we can put beavers back into headwater streams and wait. We can stop mowing the margins. We can ask with real rigor and real humility what the land was doing before we interrupted it, and then get out of the way. The Chamberlain Basin is still there. The mountains still catch snow in winter and release it slowly through spring and summer, feeding streams that move through willow corridors and past the dens of animals whose ancestors arrived, bewildered, from the sky. The ponds still hold water through August when everything else is dry. The trout still hold in the cold shade beneath the willow. The birds still find what they need in the thicket. 75 animals were set down into a wilderness. They had no instruction. They had no knowledge of what had been lost or what they were meant to restore. They only knew what beavers know, that cold water moves through wood and stone, and that a good dam is its own kind of home. And maybe that is enough. Maybe the most honest thing we can say about the natural world is that it does not need our understanding to function. It only needs our absence in the right places and our presence in the right moments to be given back what was taken. The water still moves. The roots still hold. The world, given half a chance, still knows what it is doing.